So, having discussed about one-way up freeform motion and a one-way down freeform motion, let's now proceed with the discussions by looking at the motion in two ways. Actually, in two ways, should be one way up as well as the one way down in combination. So that kind of a case is said to be ground back to a ground case, where the object has been released from the ground level and back to the ground level as well. It's said to be ground back to ground case, or two ways free fall motion. So that is, let's say we have an object on the ground level. Let's say this is the object. Should be this as the ground level. Now, assuming that the object has been thrown upwards, that should be like this. The object has been thrown upwards and are going off like this. And after some time, the object happens to now get back to the ground. Let's say in this nation. So it should be that. And what is the initial velocity? We have it as now being given as u. So that's the velocity of the object as it is being launched from the ground level up. So that is. And the point in which the object has to change back to the ground is said to be the maximum point, just as the way discussed about the way up motion of the free fall. So this is said to be the maximum point. And the velocity here, we said it is given as a Vmax. So velocity is given as a Vmax, which is always 0 unless otherwise. And we discussed that the time takes for the object to move from a down up to this point is said to be the Tmax. So we discussed all these things in the case we discussed about way up motion. So that is Tmax. So we have it as Tmax. And the distance from the level ground to the maximum point is said to be the maximum height, which is given as now. It is given as this. It is given as this distance, and which is given as now, to say it is given as a maximum height given as h. And now, what is the final velocity of the object as it strikes the ground? So have it as a v. That's the final velocity of the object as it strikes the ground. So now, since this is what you call ground back to ground case or two ways case, then think about this. We already discussed about how can be able to have the time from down here to this point, and how can be able to have the initial velocity from this point to this point, and how can be able to have this as the maximum height from the ground level up to up here. So all this we discussed about. So just have to ensure that before this lesson, you should have to go through those lessons for you to understand things. Otherwise, you just have to apply the concept here. So, how can you be able to have, what is the displacement for the whole entire journey? What is the displacement for the whole entire journey? So you see that displacement given as s, it is the same as given as h, which is equal to 0. Since the object has been thrown from actually from the ground level back to the ground level, it means displacement is given as 0. So that is, so which means overall displacement is given as 0 for the whole entire journey from the ground back to the ground. So that is. So how can you be able to have the final velocity for this case? So that is from the ground back to the ground. What is the final velocity? So we use this formula, which is given as, that should be this, let me just have to, final velocity is given as v is equal to u square, should be u square plus, should be u square plus 2as. So now should be v square is equal to u square plus 2as. Now free fall motion, we'll have this as the final velocity, which is this one, and that is given as the initial velocity, which is this one square, minus 2gh. So that is, although the object is said to be going up and down, but the acceleration due to the gravity will be negative. So now you still have to understand that the overall displacement will be given as L, hence this h is given as L. So have v square is equal to u square. So now you can see that the velocity in which the object has been released with up, it will be the same velocity the object will have to strike the ground with. Only that the final velocity will be given as the negative because it is pointing towards the negative direction. So this case you have to understand that the final velocity is the same as the negative initial velocity. You see that one? Or else, and also how can you be able to have the final, I should have to say, how can you be able to have the time for the whole entire journey? What can be the time for the whole entire journey? How can you be able to have that out? So, since this is the ground back to ground case of the free fall motion, at t max, the time for the object to raise from the ground level to this point is the same as 2 times t total. So you have to say 2 times t total. So which means if we know the, I should have to send this way. Sorry, but I should have to send this way. So what is the total time for the whole entire journey from this point back to this point? So you have to understand that the total time given as t total is equal to 2 times t max. So which means if we know the total time in which the object has to move from here up to this point, the time in which the object has been in the flight, then times 2. Actually, if we know the total time the object has been in the flight, it means divide by 2 will have the t max. So that is, so which means the time takes for the object to move from here up here, it is the same time the object has to move from here up to here. That is the t total. So which means the t max can be obtained from t total being given as now t total over 2. So take note of that. And also, how can you be able to have the t total for the whole entire journey? So we use the formula displacement is equal to ut plus half ad square, where this is the displacement is equal to ut, this is now our t total, and minus half gt total square, of which this is 0 because that's the displacement. So in this case we'll be able to have, now in this case we'll be able to have the t total will have 0 is equal to ut total. So it should be now this ut subscript, so t total minus half g t total square. So this is the formula you have to use to have the t total. If we have the initial velocity, we'll be able to have the t total using that formula. Or else we can also use this formula so to have the t total for the whole entire journey. So have v is equal to ad plus u. So now since this is the free fall, we'll have it as final velocity is equal to negative g d dot and that plus u, where this is d dot. Or else if we have the d dot in the initial velocity, we can be able to have the final velocity using this formula as well. Now as you can see, we can also be able to have the d dot using this formula as well. So should be, so we have displacement is equal to u plus v over 2 times d. In free fall, this is given as height, which is displacement, u plus v over 2 times. Now this is d dot. So in this case, this is the initial velocity, this is the final velocity, of which the displacement is given as also have a 0 is equal to u plus v over 2 times d dot. So take note of that. So which means if we have the initial final, we can be able to have the d dot using that formula. So now you know what is that kind of analysis. How do you do it as well? So how can we be able to have the initial velocity if we have the d dot? How can we be able to have the initial velocity if we have the d dot? So we use the displacement is equal to ut plus half ad square. Now we need this one. So in this case, s is given as the height, which is displacement, ud, this is d dot minus half g d dot square. So this is 0. So in this case, if we have the d dot, we can be able to have the initial velocity using this formula. So that is, or else we can also use, we can also have to calculate, we can also have to calculate the Dmax first, so that we should have to use, we should have to have the Dmax first. Then upon having the Dmax, we can also use this formula as well. I should say, upon having the Dmax, we can have used this formula. So v is equal to ut should be 80, should be 80 plus u, where this is now Vmax. So have this one as a Vmax is equal now negative, now this is Tmax plus u. You'll be able to have the initial velocity, where the object from here up to this point. So please take note of the way we are analyzing this case of the projectile motion, okay, this case of the free fall motion. So sort of I'm expressing because you know you also have to understand about the projectile motion in case your level allows you to have that. But basically in secondary school we don't look at the projectile motion. So for the secondary students, you just have to look at the free fall motion. So you forgive me because basically confusing myself. So anyways, you are getting high and high, you'll be able to understand what is projectile motion. But now you should have to understand about the free fall motion in that case. So having the knowledge of the analysis of the motion in that case, then it will help you to have to master different questions, to have to dug up different questions to do with the free fall motion. So that is